Today, we're going to be graphing quadratics in vertex form. So take a second, as always, pause your video, and I want you to try the ignite at the top of the page. Answers are up. So first step, that when you went ahead and solved this, if you're going to go with your first step to solving by graphing, or to graphing this function, is we want to start by finding that axis of symmetry. So if you plug it into negative b over 2a, b is negative 4. So opposite of 4 goes on the top, plug in your a value of 2 on the denominator, and then simplify. So we get an axis of symmetry of x equals 1, which was the answer to a on here. And then to find the vertex, we take the axis of symmetry and we plug it into the function. We plug a 1 in for every x in the function, and then we simplify. So if you take 2 times 1 squared minus 4 times 1 minus 1, you get your final answer of negative 3, which means our vertex is now at 1, negative 3. So that actually was the first point that I plotted. To get the rest of the points, this is just a matter of typing this into our calculator and seeing what we get. So I typed it in. If you hit the graph button, you'll be able to see what the picture of this actually looks like. But remember, if you want the actual points, that's probably more useful to us than anything else. So if I go second table, it'll tell me what all of the points are. Usually, as a rule of thumb, I'm always going to recommend filling in the vertex, so 1, negative 3, and then at least picking 2 points on either side. So I did 0, negative 2, and then I did negative 1, 5. But then I also did 2, negative 1, and then I did 3, 5. Could you fill in more points? Yes. I will say on this graph, those are really the 5 nicest points to graph. All of the other ones really go off of our graph. So in this case, it kind of makes your graphing, picking your points part easier to choose from. But in terms of graphing quadratics, though, that is your typical quadratic in standard form. And as always, remember for part C, it says, does the graph have a max or a min? A min means you reach a lowest point and then you start coming back up, which is exactly what we have here. Now, a lot of times we'll say at what value. I didn't ask that, but that just means how low does it go? Which means you go as low as negative 3 on this one. Negative 3 is kind of like the lowest x value that you reach. So we would say the minimum is at negative 3. And then last but not least, we have all of our different transformations. For this one, we have 3 specifically, because the a value, which has a 2 in front, because we have an a value larger than 1, that means this graph is stretched. And because my vertex is at 1, negative 3, that moves from 0, 0, right 1, down 3, which means we have both shifts. We move right 1 and we move down 3, okay? Now, when it comes to vertex form, to be honest, vertex form is my favorite because we don't have to use a fancy formula to find our vertex. And we actually can't use the negative b over 2a formula because that only applies to standard form. In vertex form, we actually don't really have a b or a c term because vertex form looks a little something like this. It's y equals a times x minus h squared plus k. Very similar to what we used when we graphed absolute value equations. So when we graph absolute value equations, the h and the k stand for the vertex. And that's actually no different for quadratics. Even though it's a different type of function, the pieces of the equation still match up very similarly. So in this case, where hk is the vertex. Okay, so usually remember we always look at what's inside and take the opposite sign. That becomes our h value. And then whatever number is outside of the parentheses being squared, that becomes the y value. So for example, let's say we had y equals, I don't know, 1/2 x minus 4 squared plus 7. If I was going to say what the vertex is, whoa, not a w, vertex. The vertex on this one, we would take the opposite of what's inside. So opposite of what's inside is a positive 4. And then whatever number is outside, that becomes the y value. Vertex on this graph would be at 4, 7. So when we graph, I honestly think these are a little bit nicer in the sense that if I'm gonna go ahead and graph this example number 1, I already know my vertex. My vertex is gonna be, I don't even need to graph that to figure that out. Opposite of what's inside is a -4, so opposite of that is a positive 4. And then because I have a -6 on the outside, a -6 comes down, and that is my y value. So the y value doesn't change signs, it's only the x value that changes signs. Now, when it's coming to the rest of this graph, here's where you probably want to go to your calculator. Whoopsies. So if I go into my handy dandy trusty calculator, I'm going to type everything in. So parenthesis, it's going to be x minus 4, close parenthesis, and then we're going to square that. And then it's going to be minus 6. So minus 6. If you want the picture, you can just hit graph. So, and just to double check that looks right. If I go right 4 and I go down 6, that actually does end up being my vertex. So right 4, down 6. Now, if I want the other points though, I'm going to go into the table and I'm going to find my vertex, which is right here. So 4, -6 is there. And I'm going to pick some of those other points to graph. So let's see, 3, -5 is a good one. 2, -2 is great. Honestly, 0, 10, 1, 3, all of those are good. But again, you want to pick at least 2 really on either side to get a good picture of our graph. So I'm just going to pick a couple of those points. So if we type that all in, let's see, let's do a couple of them. So like left 3, down 5, right 5, down 5. And then what's the other one? Right 2, down 2, right 2, down 2. And then right 6, down 2. And there's my graph. Now you could graph more. We could fill in our graph because 0, 10 was a point. If I keep going, I think that was our point. But really in terms of graph, we want to have that nice U shape. Oh boy, that was messy. Try and go through as many of our points as possible. But there is our quadratic. Now again, if I say compare to the parent, what transformations does this have? Well, the vertex right away, this tells us that I have at least 2. We're going to have a vertical shift and a horizontal shift. Because my vertex isn't at 0, 0. My vertex is at 4, -6. So I go, my vertex moves right 4, down 6, which means all of the other points on the graph are going to move right 4, down 6. It's just the vertex is the easiest to compare. Now, in terms of all of the other transformations, all of the other ones, we would look at the a value, which in the parent function, that's the number that's in front. So this guy right here, because it's a 1, it's not really a transformation. It's not any different from the parent function. So in terms of comparing to the parents, I only really have 2 transformations. I don't have a reflection. Because it's not larger than 1, it's not a stretch. And because it's not a fraction of some sort that's in between 0 and 1, it's not a compression. So take a second. What I want you guys to do, I want you guys to pause your video and I want you to try example number 2. This guy right there. Okay, if you look, answers are up. Hopefully your graph, now this one, there's only really 3 nice points to graph. The rest kind of go off of it. So as long as you graphed, you had your vertex of -1, 3. Opposite of what's inside is we have a positive one inside. So opposite of that is a -1. And then because there's a 3 on the outside, that 3 becomes the y-coordinate. So vertex was -1, 3. The only other 2 points that were really nice to graph was 0, 5 and -2, 5. So those are the only 2 that I graph. Again, if most of them go off your graph, you don't have to graph the ones that really go off, as long as you at least have the 2 on there. Now, in terms of transformations, because we have a vertex that's not at 0, 0, because I moved left 1 down or left 1 up 3, we have both shifts. We have a horizontal, we have a horizontal and a vertical shift. But this one also has another one because there is a 2 in front. That means that we have an a value greater than 1, which is the definition of a vertical stretch. So this one also has a stretch. And that's it. So now here's the deal. You're probably saying, or you probably maybe thought this in the past. You're like, why do we have two different forms? And actually what really ends up being kind of neat is that they really actually are one and the same. It's just that for vertex form, you can convert vertex form into standard form. It's the same equation, it's just written slightly differently. So this is something that in Algebra 1, we always said that they're related. There's a reason why they graph the same graph, but we didn't go into it. In Algebra 2, that's actually what we're going to be doing first. For this one, our goal is going to be to write the quadratic in standard form. So we have to convert vertex form into standard form. And remember, standard form is ax squared plus bx plus c. And you're going to start by noticing that one of the most obvious differences is that there is no parentheses. So when we go about simplifying, that is actually what we're going to start by getting rid of. So really this f of x just kind of stays throughout the entire problem. Mostly what we're going to be working with is strictly this right-hand side. Nothing has to switch sides. It's all a matter of kind of changing this and end up multiplying. Because when I'm squaring something, that's exactly what squaring something means. It means take that thing and multiply it by itself twice. So that's actually one of the first things that we're going to do. If I'm squaring x minus 4, that means I'm going to multiply it by itself twice. So we're going to expand that x minus 4 into its two separate quantities. And my first step is always, even if there's a coefficient out in front, my first step is always going to be to multiply those two pieces together. Now remember, when you multiply, you should be left with 4 separate terms to start with. So the 3 I'm going to keep there. When I multiply those pieces out, I'm going to put all of those just in parentheses, and they're going to kind of chill together for a minute. Okay, so we're going to start by distributing. So my first step is going to take the x times the x, which x times x gives me my squared. Then I'm going to take x times -4, and we're going to get -4x. Then we're going to move on. We're going to get -4 times x, which is going to be -4x. And last but not least, -4 times -4, which is going to be a +16. Now we're here. Now it's a matter of really combining like terms. So that's my first step before I distribute that 3. I'm going to go ahead and I'm going to combine those together. So it's going to be x squared minus 8x plus 16, and then the 5 is still going to chill on the end. Now that we've multiplied my quantity out, now is where we're going to go ahead and we're going to now distribute the 3 out in front. So this 3 is going to get multiplied to each of those pieces on the inside. Oops, okay. So when I distribute the 3 times x is going to end up being a 3x. 3 times -8 is going to end up being a -24x. And last but not least, 3 times 16 is going to end up being a 48, which my very last step, we always want to combine as many like terms as possible. And we have another set of like terms because 48 and 5 can be added together. So 48 plus 5 ends up being 53. And there is your vertex form of the same exact equation, which is pretty awesome. Now, if you didn't believe me, this is something, or if you weren't sure, the cool thing is you could go about graphing both of these. If I wanted to say, okay, well, this one, our answer was 3, what was it? In parentheses, it was x minus 4 squared, and then plus 5. So if I graph that, you're going to notice that one's going to be graphed in blue. But I'm going to, in the second y2, I'm going to arrow down, and I'm going to actually type in my standard form. So if I go if I go 3x squared minus 24x, nope, just kidding, minus 24x, and then plus 53, you guys are going to see something cool happen. If I hit graph, it's going to graph it in red, but do you notice how it graphed it over it? That's because it's the same equation. It's just the vertex form is what we started with, and what we ended with was our standard form. So I want you guys to now take a minute. Oh, I didn't show you guys on the video. I'm so sorry. But if you guys notice, if you graph them in both in your y equals, you'll notice that they actually should graph on top of each other. They should produce basically the same exact graph. So you guys will notice actually if I delete the red equation, the blue equation is going to show up in the same exact spot. So in case you wanted to check, you can always check your calculator. But sorry about that, guys. I didn't mean to do that. But if you go back to your notes packet, what I want you to do right now is I want you to pause your video and I want you to try example 4. Answer, you should have got y equals 4x squared minus 16x plus 15. So just double check your first step should have been, and I'll show it in highlighter, first step should have been to expand that x minus 2, since that's what's being squared. X minus 2 squared is x minus 2 times x minus 2. So second step is then to actually multiply that out. If I distribute, x times x becomes our x squared. X times negative 2 becomes our negative 2x. Negative 2 times x ends up being negative 2x. And last but not least, negative 2 times negative 2 is a positive 4. Which final, in terms of working with those parentheses, really the last step with those is to then just distribute the 4. So if I multiply 4 to each of those things in the parentheses, you should get 4x squared minus 16x plus 16, which final step then is then to combine your like terms. 16 minus 1 ends up being your 15, okay? So final answer, you should have got this guy right there, okay? Now, in terms of solving, that's kind of it for today. If you would like to pause your video, I'm sorry, the hiccups, guys. If you want to pause your video, I will write in the answers for the UTriNows 1 and 2. Answers are as follows. They're up. Obviously, these are some things where we can go over these in class, or we might be going over in class. But if you want to check your answers and see if you're correct, here they are. Good luck, guys. If you have any questions, you guys know the drill. Just email Miss Hardy, and you can meet her in office hours.